Welcome. My name is Mark, and I am a huge fan and enthusiast of Mars. For many years, I have been fascinated by this red planet and have studied the concept of terraforming. In today's episode, I want to share my knowledge, thoughts, and ideas about whether we can turn Mars into our new home. Is this just a science fiction dream, or could it become reality? Let's take a closer look at what terraforming is, our chances of achieving it, and the challenges we must overcome. Before we begin, here are some fascinating facts about Mars. Mars has the largest mountain in the solar system, Olympus Mons, which is over 21 kilometers, 13 miles high. The red planet also has the deepest canyon, Valles Marineris, which is 10 times longer and 5 times deeper than the Grand Canyon in the USA. Interestingly, a Martian year lasts 687 Earth days, and due to its thin atmosphere, massive dust storms can engulf the entire planet. Mars is half the size of Earth, and its lowest temperatures can drop to minus 125 degrees Celsius, or negative 193 degrees Fahrenheit. Can we really turn this desolate world into a second Earth? Let's find out. What is terraforming? Terraforming is the process of transforming a hostile planetary environment into a place suitable for human life. Imagine adding an atmosphere, increasing the temperature, and creating conditions that would allow humans to live just as they do on Earth. The first ideas about terraforming appeared in science fiction literature in the 1950s, but it was Carl Sagan who first proposed a scientific approach to changing Mars in the 1970s. Sagan suggested using the greenhouse effect to heat the surface of Mars and release gases from its polar ice caps, potentially jump-starting the formation of an atmosphere. He was not only a brilliant scientist, but also a visionary who believed that humanity could become an interplanetary species. His ideas inspired generations of scientists, and his book Cosmos continues to encourage people to explore the universe. Imagine Mars changing step by step. First, we create an atmosphere, then water, and finally we introduce plant life. Sounds simple, right? But how do we actually do it? Why Mars? Mars is not only the closest planet to Earth, but also the best candidate for terraforming. First, it has water in the form of ice, which is the key to life. Second, its day length is very similar to Earth's, about 24 hours and 37 minutes. And third, Mars already has an atmosphere, although it is very thin, which gives us a foundation to build upon. But why not Venus? Even though Venus is similar in size to Earth, it is a hellish world. Its temperatures reach 450 degrees Celsius, or 842 degrees Fahrenheit, and its atmosphere is mostly composed of carbon dioxide and sulfuric acid. Mars, though cold and dry, gives us far more possibilities. How could we terraform Mars? Scientists propose 3 main approaches. First, heating the planet. This could be done in several ways. One idea is to use massive orbital mirrors to reflect sunlight onto the surface of Mars, melting its ice caps and releasing carbon dioxide. Another method is to introduce greenhouse gases, creating an artificial greenhouse effect. Second, introducing oxygen. This could be achieved by growing special microorganisms, such as cyanobacteria, which produce oxygen through photosynthesis. Imagine Martian oceans filled with these microbes. And third, melting the polar ice caps. Nuclear or solar energy could release vast amounts of water and carbon dioxide, speeding up the process of atmosphere formation. Each of these methods is fascinating, but also full of challenges. Major challenges of terraforming. Before we even begin terraforming, we must solve some critical problems. First of all, how do we get to Mars and survive there for long periods? A journey to Mars takes about 6 to 9 months, and astronauts will face isolation, cosmic radiation, and limited resources. We need advanced life support systems, resource management solutions, and technologies to protect against harmful radiation. Additionally, the terraforming process could take hundreds, if not thousands, of years, and any atmosphere we create could be eroded by solar winds due to the lack of a magnetic field. The biggest problem: no magnetic field on Earth. Our magnetic field protects our atmosphere from solar wind. Mars lacks this protection, which means that any atmosphere we create could literally be blown away into space. Another issue is time. Terraforming Mars could take hundreds or thousands of years. This is not something we will see in our lifetime. And then there are the costs. We are talking about projects that could cost trillions of dollars. Is humanity ready for such an expense? And there are even deeper questions. What if there is microbial life on Mars? Do we have the right to change a planet that could already be home to unknown life forms? Is terraforming an escape from Earth's problems? Should we invest massive resources into terraforming Mars while Earth is struggling with climate change, pollution, and overpopulation? Some critics argue that terraforming is an escape from responsibility, a distraction from fixing our own planet. Should we not save Earth first before trying to colonize other worlds? However, Mars exploration could provide technologies that help solve Earth's problems. For example, developing life support systems for Mars could revolutionize agriculture in Earth's dry regions. Maybe these two goals are not mutually exclusive. So is terraforming Mars possible? Today, it is still a challenge that seems like science fiction. But history shows that what once seemed impossible can become reality. Just look at space travel. In just a few decades, we have gone from the first human in space to a permanent presence on the International Space Station. Maybe it will take decades, maybe centuries, but if humanity takes on this challenge, Mars could become our second home. Thank you for joining me in this episode. This is just one of the first videos on our channel, which will cover not only terraforming Mars, but also the technology, biology, and science behind this incredible process. In upcoming episodes, we will dive deeper into the technical, ethical, and scientific aspects of Mars colonization. If you are curious about the challenges and opportunities of making Mars habitable, stay with us. Now, a question for you. What do you think about terraforming Mars? Is it a good idea, or should we focus on protecting Earth first? Share your thoughts in the comments, and don't forget to subscribe to our channel for more content about the future of the Red Planet. Thank you for watching, and see you in the next episode.